hello everybody, namaskaar, Sri Akal. I am Mallikarjun Patil and this is Patil's virtual classes. Yes guys, in today's class we will be discussing a new chapter in the Patil's virtual classes, that is probability. Probability is one of the important chapter in which it starts in the 8th standard, 9th standard, 10th standard, first year, second year. In all the standards we will be discussing the probability chapter as you go on studying in the maths, right? So before going to start with the chapter, we should know what exactly the probability is. What is the meaning of probability? And the reason behind this, why we need to study the probability, right? So here on the screen, as you all can see, there are some things are there which we mentioned here. You can see that in the diagram here some targets are there, some games are there, and here you can see the cards also. And what these all games related, how they are related to this probability, what exactly this probability is. Whenever we play a game, there are two chances. One will be either we may win or we may lose, right? So how we can decide that winning and losing a game? See, there will be only winning and losing a game, or you may say that so there may be a chances of uh, either winning or losing, or and sometimes there may be a draw, right? So this we can decide by knowing the probability, that whatever the tricks we can use to use the probability in the games, that only we will use. For example, tossing a coin to get who will play first. Why we will use the tossing a coin only? The reason behind that is probability, because tossing a coin is a equally likely event. Equally it is going to divide, it will be providing same facility for the both the teams. That is the reason why we will use. And what exactly this probability is? This probability is the chances of occurring an event, that is called probability. Probably I may come, probably it may rain, we will tell, right? Means chances are there. That is the reason why we will be using the word probability in all those things, right? So this is about the simple definition of probability, and we will be discussing this right now. Here you can see, okay, the difference between what is experimental and theoretical probability, and what exactly the probability and how you will be dealing it. Theoretical probability is the probability of an event. We used to tell the probability of an event E can be written as P of E. This is written as P of E. How we will read this? We will read this as probability of an event E is equals to number of outcomes in the favorable event E divided by total number of possible outcomes. What is this number of favorable outcomes and the total number of outcomes? I'll tell. See, if we take just a simple example, I will take, if we take tossing a coin, in case of toss, if we were tossing a coin, what result we may get? We may get two results. One is head, one is tail. Right? That both are, if we take it in the sample space, we will be writing here all the possible outcomes. If a coin is tossed, what all are the possible outcomes? Full outcomes, whatever it may be. That is, see, there exists one head, there exists one tail. So after tossing a coin, it should be either head or tail. Nothing else will come other than this, right? So this is total event outcomes. Total after tossing a coin, total events. How many? Two events are there. Out of these two, I need to select one. We need to select. We need to call for either head or tail. That whatever I prefer, what we want from that total outcomes. To in that total outcomes, we want something, and that whatever our favorable is there, that is called favorable event. That is called favorable event. For example, if I am going to choose head here from this, if I am going to choose head, then head is my favorable. The number of outcomes. How many heads are there here? Only one head is there. Divided by, see, my favorable is only one. Out of how many total are there? Two are there. So if we divide 1 by 2, what we'll get? We'll get this probability of event E. And what is the event here? Getting a head is my event. If I want getting a tail, again same you need to do. Is that clear? So this is a simple example and the practical representation how we will be using the probability formula. Clear? And the next thing is, the probability of a sure event is 1. Any event may happen. The happening of an event, probability of happening of an event is 1. And in similar way, the probability of impossible event, the probability of not happening of an event is 0. Right? See, for example, tossing a coin and getting a number 6. Is it possible? I am tossing a coin and getting a number 6. Is it possible? No, that event is not possible. That is called impossible event, and the probability of such impossible event will be 0. Throwing a die, getting head. Is it possible? It is impossible. Right? So such impossible event will be having the 0 probability. The next one is the probability of an event E, and it is represented as probability of E, such as it will be in between. This will be less than, this will be less than. The probability of an event E will be less than 0 and less than 1. Means the probability of an event will be between 0 to 1. It will be between 0 to 1. The next one is what is the probability? An event having only one outcome is called as elementary event. So the sum of the probabilities of all the elementary event of an experiment is 1. See, if the probability of all the events, if you are adding, sum means addition. If you are adding the probability of all the events, and that sum should be always 1 only. That is, if you take head and tail, the probability of getting head is 1 by 2 plus the probability of getting head is 1 by 2. 1 by 2 plus 1 by 2 half plus half is 1. So this is how the sum of probability of all event is always 1. Then at last we have the probability of any event which is happening, probability of E and probability of E bar or not happening of an event is 1. Where E stands for not E. E bar. E bar stands for not E. And E and E bar are called as complementary events. One is probability of happening event, one is probability of not happening events. Is that clear? So these all are the basic concepts, some basic concept you should know about probability. Clear? If you know these all, directly we can go for solving the exercise. I hope this is clear. If you found still any difficulty, please do comment me so that I can solve your doubt. Can we go for exercise? Okay. So here is the exercise 9.1. First question I am going to read, and question number 1. Complete the following statements or fill in the blanks they are given actually. The probability of an event E and the probability of an event not E means the probability of happening of an event and not happening of an event will be equals to how much? Just now we discussed that will be equals to 1. Right? The next one is the probability of an event that cannot happen. Any of the event which is not happening, the probability of such event will be 0. The probability of an event which is not happening will be 0. Right? And such events are called as, just now we discussed, impossible. Such events are called as impossible events. Right? The next is the probability of an event that is certain to happen is called as, it is going to happen only, that is called as sure event. That is called as sure. The probability they are asking here, and the probability of a sure event is 1. Probability asking the probability of an event certain to happen is 1. Any event, and such events are called as sure event. Just we discussed tossing a coin. The probability of tossing a coin is 1. Means both the events if you add, and such events are called as surely either head will come or tail will come. Surely either any one out of these to come. Right? The next one is the sum of probabilities of all the elementary events of an experiment is, just now we discussed, it will be always 1. Sum means addition of all the events. The probability of an event is greater than or equal to and less than or equal to what? See, greater than and equal to, here this will come actually fill in blanks here. The probability an event is always greater than or equal to 0. The probability may be 0 or greater than 0 and less than or equals to 1. This implies the probability of an event will be varies between 0 to 1. It will be varying between 0 to 1. This is clear. So this is about first bit of the exercise. We will go for next one. Is that clear? Question number 2. Which of the following experiment have equally likely outcomes? Explain. Equally likely means either possible or not possible. Only that should be there. Equally likely it should be divided. For example, first we have A driver attempts to start a car. The car starts or does not start. See, a driver is trying to start the car. We don't know whether the car starts or not. This is equally likely event or not. And I'll tell this is not. This is not equally likely event because see the driver may be good driver, but it depends on the condition of the car. Condition of the car. The car may be good or may not be good, or whether it depends. Right? If something is depending on that particular concept, we can't tell it is a equally likely event. Right? The next one is a player attempts to shoot a basketball. It is also equally, it's also not equally likely. He or she shoots or misses the shot. It depends on the ability of the particular player. So that's why I consider this is also not equally likely event. A trial is made to answer a true or false question. The answer is right or wrong. You tell this whether it is equally likely or not. See, there are only two possibilities are there here, whether he may be good, bad, intelligent or not. Out of these two, anyone he will choose. Either has to choose true or false. Between these two, anyone he or she should select. Right. So that's why yes, this is called or this is equally likely event. A baby born is either boy or a girl. Now you decide whether it is equally likely or not. Yes, it is equally likely experiment or equally likely event. Is that clear? Can we go for next one? Question number 3. Question number 3. Why tossing a coin is considered to be a fair by the way deciding which team should get ball at the beginning of the football game? Why? Why he is asking why tossing a coin? As just now we will be discussed because tossing a coin is a fair event because it is a equally likely event. It is a equally likely event. Means that is going to provide us equal authority for the both of the teams. And the possible outcomes are 1 by 2, 50-50. 50-50 chances are there. We will be dividing the chance into both of the teams. That is, probability of getting head is also 1 by 2 and the probability of getting tail is also 1 by 2. Whatever they may select, both of they will be having same chances of winning the toss. Right? That is the reason. The next one is which one out of this cannot be probability of an event. The probability of an event is 2 by 3 minus 1.5, 15%, 0.7. Out of these 1, 2, 3, 4 options, which one is not they are asking? Which is not? Which cannot be the probability. See, the probability may be 2 by 3. Is it possible or not? See, 2 by 3. What is the value of 2 by 3? Is it 2 by 3? 3 1 ja 3.6. This 0.6 is between 0 to 1. It is between 0 to 1. So there may be chances of having the probability of 2 by 3. The probability, as we discussed, the probability of an event will be 0 to 1. But what we get here is minus 1.5. The probability of an event is, it will not be in the negative. It will not be in the negative value. So this 1.5 is not. 1.5 is not. So I am going to show it once again. This second B, that is 1.5, is this is not going to be the value of any of the probability. 15% may be there. 0.7 is also between 0 to 1. It is between 0 and 1. So 0.7 is also there may be a chances of having 0.7 also. But minus 1.5 is not the value of any probability. Is that clear? Can we go for next question? Okay, the next question is the probability. They gave here some probabilities and we need to find the value. In the question number 5, the probability of an event they given is 0.05. What is the probability of not happening? See, they given the probability of happening of an event. They are asking you to find the probability of not happening of an event. So what is the sum of probability of, see, sum of probability of happening of an event plus probability of not happening of the event should be equals to 1. And here the probability of happening of event we got how much is 0.05 plus probability of not happening we don't know. We need to find this. So probability is 1 minus this 0.05 will go that side, it will be minus 0.05. What is the answer? 1 minus 0.05. The answer is 0.95. This is probability of not happening of an event. Clear? The probability of not E. Right. And question number 6. Here, a bag contains lemon flavored candies only. In that bag, only lemon flavored candies are there. Malini takes out one candy without looking into the bag. What is the probability that she takes out a orange flavored candy? In the bag, only lemon are there. What is the probability of orange? They were asking. Now you decide whether it is a possible event or not. It is an impossible event. And what is the probability of impossible event is 0. Therefore, the probability of this event is 0. And what is the probability of a lemon flavored event? See, lemon flavored candies are there. She will get lemon flavored candy only. So such probability will be equal to 1. That is a possible event. Only that is possible, and only that one thing is there. So that is the reason why the probability of getting the lemon flavored is 1. Clear? Then can we go for question number 7? Question number 7. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability of 2 students having the same birthday? Okay, here different means reverse the given. So in the given question, they given probability of not happening of the event is 0.992. They are asking you to find the probability of happening of the event is equals to how much. As we all know, sum of these two should be equals to 1. That is probability of happening plus probability of not happening of event should be equals to 1. Happening of the event we don't know, and probability of not happening we know 0.992, which both should be equals to 1. Now what we can do, this 0.092 we can take this side, and the probability of E will be 1 minus 0.992. What is the answer? Probability of 1 minus 0.992 is 0.008. This is the probability of that the students can have same birthday. Right? Next we go for question number 8. A bag contains 3 red balls, 5 black balls. A ball is drawn at the random from the bag. What is the probability that the ball drawn is red and not red? Red and not red. So what we can write here? I will take probability, let probability of E, which is the took ball, first one is red. Right. So there are number of red balls divided by total number of balls. We can take how many red balls are there? 3 red balls are there. How many total balls are there? How many total? 3 and 5. 8 total balls are there. So 3 by 8. What is this 3 by 8? This is the probability of getting a red ball. This is probability of happening of an event. Either you do this, or if you want you can go for probability of not happening, means the probability of not red. Not red means 1 minus 3 by 8. See, not happening events we did here, how it will be 1 minus it will come, that we discuss directly, you can write now. So here the LCM is 8, here into 8 into 1, that is 8 minus 3. How much? 5 by 8. See, either you can do the probability of not happening of an event as 1 minus 3 by 8, or you can go for doing the remaining ball after if except red. How many balls are there? 5 balls are there. That 5 divided by total will be 8. That also you can write, or you can solve it like this also. So this is means we need to use the relation of probability of happening of an event and probability of not happening of an event. Am I clear? Then we will go for question number 9. Question number 9. A box contains 5 marbles, 5 red marbles, 8 white marbles, 4 green marbles. 1 marble is taken out from the box at the random. What is the probability that the marble taken out will be either red, first question, white, second question, not green is the third question. So what we will write? We will write solution. We will write given. Total number of marbles we will found first. Total marbles. Total how many marbles are there? 5 plus 8 plus 4. How much? Total there are 17 marbles are there. out of which 5 red, 4 white and 4 green, 8 white, 8 white marbles are there. First question, what is the probability of getting a red color marble? So probability of getting red color marble, or we can write this probability of R, or probability of E1, E2, E3, you can consider. E1 event is equals to probability of getting a red. How many red marbles are there? There are 5 red marbles. 5 divided by total number of marbles 17. So it will be 5 by 17. And second one is what is the probability that the taken out marble is white? How many? So I will take this as probability of event E2. So how many white color marbles are there? 8 white color marbles are there. Total number of marbles 17. So it is 8 by 17. And third one is probability of the ball or the marble which we selected is not green. What we need to do here is, so probability, or we can take this as E3. Not green means except green. If we remove green, how many are there? 5 plus 8 balls, marbles are remaining. That is 13 marbles are remaining. So the answer will be total 13 balls divided by 70. Total number of marbles. So this is the probability of red, probability of white. This is the probability of not green. What will be probability of green? This is the probability of not green. Please do find the probability of the taken out marble is green color and comment the answer. So what is, I will write the question here. What is probability of, I will see how many of you will write the answer. Probability of getting green marble is how much? What is the probability of getting green marble? Please do find the answer and comment your answer. I will see. Next question. Question number 10. A piggy bank contains 150 coins, 51 rupees coins, and 22 rupees coins, and 10 5 rupees coins. If it is equally likely event that one coin will fall out whenever the bank is turned upside down, and what is the probability of the coin which is coming out from the that piggy bank is 50 paisa, a 50 paisa coin, and it is not a 50 paisa coin or 5 rupees coin, that we need to find. So what I will do now, first I will write solution. I will find total number of coins. See, here is 150 paisa, 100 coins, 1 rupees, 1 rupees, 50 coins, rupees, 2 rupees, 20 coins, 5 rupees, 10 coins. Now you can write total how many? 180 coins are there totally. Totally there are 180 coins are there. Now what we need to find, first one is what will be the probability of that event which the coming out coin should be 50 rupees coin. So I will take therefore the probability of E is equal to number of 50 rupees coins, number of 50 paisa coins divided by total. Total what? Total number of coins. Number of 50 rupees coins, 50 paisa coins. How many 50 paisa coins are there? 150 paisa coins are there. So it will be 100 divided by total number of coins is 180. 100 by 180. If we remove 0 by 0, 2 5 the 10, 2 6 the 2 9 the 18. So it is 5 by 9. What is 5 by 9? 5 by 9 is the probability of getting a 50 paisa coin. Right, then second one is what will be the probability of not 5 rupees coin, means except 5 rupees we need to add all. In the out of 180 coins, how many 5 rupees coins are there? 10 5 rupees coins are there. If we remove the 10 from the 180, remaining is 170, right? So therefore, the probability of, I will take that event as E2 if we consider this as even. So that will be 170 by total number of coins is 180. So if we remove 0, 0, what is remaining? 17 by 18 is remaining. So this is what the probability of that coin will be, not 5 rupees. This is about question number 10. Can we go for 11th question? Okay. Here is question number 11. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing the 5 male fish and 8 female fish. You can see it in the figure. What is the probability that the fish taken out from the fish tank is male only? It is a simple question. Right solution. See the number of male fish. How many? 5 male fishes are there, and a number of female, how many number of female fish, how many? 8 are there, and total will be how much? 13 fishes are there. Out of 13, one fish is remaining, right? What is the probability of the taken of fish is male only? Therefore, probability of, or you can write it in the word, probability of male fish is equals to total number of male fish is 5 divided by total number of fishes is 13. So the answer is 5 by 13. Forward. Only one question is asking, and what will be the number of female probability of a female fish? Please to find and comment your answer so that we can go for question number. Can we go for question number 12? Here it is, question number 12. A game of chance consists of a spinning an arrow which comes to rest to a point at one of the number 1, 2, 3, 4, 5, 6, 7, 8 dash. You can see in the figure. What is, these are equally likely variables, outcomes. What is the probability that will point at 8? How many outcomes are there that we need to do first? First one is probability of getting the outcome as 8 only. How many 8 are there in this total game? How many 8s are there? Only one 8 is there. So only one 8 divided by how many total numbers are there? 1, 2, 3, 4, 5, 6, 7, 8. 8. So the probability of getting 8 is 1 by 8. Then second one is probability of getting an odd number. Probability of getting an odd number. Here you can see how many odd numbers are there. 1 odd number, 2 odd number, 3 odd number, 4 odd numbers, 4 odd numbers. Divided by total how many numbers? Total 8 numbers. So the probability is 4 by 8. Or if you divide it, 4 1 the 4, 4 to the 8. The probability is 1 by 2. Clear? Then in third question, they are asking you to find the probability of a number greater than 2. Greater than 2 it should be. How many greater than 2 numbers are there? So I will clear this so that you can find the greater than 2 numbers. Out of 1, 2, 3, 4, 5, 6, 7, 8, how many numbers are greater than 2 are there? So 1, 2, 3, 4, 5, 6 numbers are there which are greater than 2. So the probability of getting a number greater than 2, or how many are there? 1, 2, 3, 4, 5, 6 are there. So it will be 6 by 8. That is 2 3s are 2 4s are. The probability will be 3 by 4 is the total probability. Then fourth one is the probability of the number which we will get the sum. The number will be less than 8. The number will be less than 8 that we need to find here. Here you can see there are all the numbers 1, 2, 3, 4, 5, 6, 7, 8. All numbers are less than 9 only. So the probability of getting a number less than 9 is equals to all numbers 8 by 8. That is 8 1 the 8 1 the, and the answer is 1. So the probability of getting a number less than 9 in this particular event is 1. And how we will getting that one is 8 by 8. Is that clear? Can we go for next question? Question number 13. We will go for question number 13. Here the question is, a die is thrown once, find the probability of getting a prime number, find the probability of getting a number lying between 2 and 6, find the probability of getting an odd number. So what are the all outcomes are there? Write that in the sample space. See, a die is thrown. After throwing a die, what is the chances of getting a number? We may get 1, we may get 2, we may get 3, we may get 4, we may get 5, and we may get 6. Out of these 6, first question is asking is what is the probability of getting a prime number? Probability of getting a prime. What is prime number? Prime number is a number which will be having only two factors, either 1 or itself, right? So out of these two, how many what all are the prime numbers are there? These 2, 3 and 5 are the prime numbers. How many prime numbers are there? 3 prime numbers are there. How many? 3 divided by how many total numbers are there? 1, 2, 3, 4, 5, 6 total numbers are there. This is the probability of getting a prime number. Divide and write the answer as 1 by 2. 1 by 2. Then question number 2. Here he is asking what is the probability of a number lying between 2 and 6. Here is 2, here is 6. In between this 2 and 6, how many numbers are there? 1, 2, 3 numbers are there. And what is the probability of getting this number? Either 3 or 4 or 5. Out of these three, any one number you should get. What is the probability of that thing he is asking? So probability of getting a number between 2 and 6 is equals how many numbers are there? Again 3 by 6. Again 3 1 ja 3 2 ja. And again the answer is 1 by 2. Third one is what is the probability of getting an odd number? Here out of 1 2 3 4 5 6, how many odd numbers are there? 3 odd numbers are there. One is 1, one is 3, one is 5. 3 odd numbers are there. Again it is also 3 by 6. 3 1 ja 3 2 ja. And the answer is 1 by 2. See in question number 13, probability of getting a prime number is also 1 by 2. Probability of getting the number between 2 and 6 is also 1 by 2, and the probability of getting an odd number is also 1 by 2. All these answers 1 by 2, 1 by 2, 1 by 2. Is that clear? Okay, can we go for next question? In question number 14, yeah, this question is something different, that is related to cards. Who will be playing the cards? That will be easy for them to do, and who not, they may get some difficulty in this. I'll explain. One card is drawn from a well shuffled deck of 52 cards, out of which find the probability of getting a card which you are getting out from that 52 cards is a king of red color only, a face card, a red face card, a jack of hearts, a spade, and the queen of diamonds. All shades will be having one queen in each, out of which we need to find one. How many such numbers are there? That I am going to tell you. See, in a red color there are only two king will be there. In face a face card, how many face card will be there? 12 face card will be there. Each 4 will be there. 3 card each will be there. And a red colored face, how many red colored face card will be there? 6 red colored face card will be there. And only one. See, it should be jack of heart they given. There will be only one jack of heart. It will be there. And how many spade colors are there? 13 spade colors are there. And at last, how many queen of diamonds? There will be only one queen of diamonds. How we will getting this in a separate class? I will explain about all the cards and that all things. Simple basic is out of 52 cards. We will divide this 52 cards into 13, 13, 13, 13. Right, out of this 13, again all 13 numbers is divided into 10 plus 3. These number are different, these number are different. 1 to 10 cards will be there, and this here 1 2 3 different 3 cards are there. Out of this 52 cards, 26 and 26 we will go for red and black, out of which, right? So this is some basic concept of cards are there. Some one chart I will do better, I will explain it in the next class, how many cards and what will be the different colors and number of states and those are things, right? So here this question is solved already. So these all are the different values how many we will be having in the given particular question. If you divide it with the total number of cards, that is 52, you will get the probability, that is 2 by 52 is the first answer, that is 2 1 ja, 2 2 ja, 2 6 ja, that is 1 by 26. And in second question, 12 by 52, 12 by 52 is 4 3 ja 12, 4 1 ja, 4 3 ja 12, 3 by 13 is the second answer. And in third question, that is 6 by 52, again 2 3 ja, 2 2 ja, 2 6 ja, it is 3 by 26. And in fourth one, 1 by 52 is the answer directly. In fifth one, 13, as I told here, 13 spades will be there. 13 by 52, 1 ja, 4 ja, that is 1 by 4. At last we have how many? Only one queen in the diamond. 1 by 52 will be the answer. See, this question you can solve this question only if you know this complete knowledge of cards. Then only it is possible, right? So can we go for next question, all of you? It is also based on the card, but here I think we should not have that much knowledge about cards. Then also we can solve this. Five cards are there. That is 10 number card is there. A jack is there. A queen, a king, and an ace of diamond. These five cards are there. Are well shuffled with their face downwards. They kept five cards. One card is picked up at the random. What is the probability that the card is queen? Out of five, one is queen only. That is the probability will be anyhow. We can write this here only. There is only one queen out of five. One out of five. This is the probability of getting the card maybe queen. In second question, if the queen is drawn and put aside, means we were not replacing it. We are not keeping it at the same place. We have seen a card, and if it is queen, we will keep aside. And how many number of cards are remaining there out of four? Now four cards only remain, right, out of five. What is the probability that the second card picked will be an ace and or a queen? See, there are four cards left now, out of which one is ace. So the probability of getting an ace will be 1 by 4. This is a answer. And in second, there is no queen. Out of five cards, I will draw here and explain you. 1, 2, 3, 4, 5 cards are there. Out of five cards, one is a 10 number card, one is a jack, one is a queen, one is a king, one is a ace. Out of this, we have removed this card. We removed this card. This card is not there now. How many cards left? Four cards left. Out of four, how many? What is the probability of getting an ace? They are asking. How many ace are there? One ace. So the probability is 1 by 4. Now, in this condition, what is the probability of getting a queen? Out of this four, what is the probability of getting a queen? Four cards are there. Right? No queen is there. No queen means no event. Event is not possible. It is an impossible event, and the probability of impossible event will be 0. So the probability of the second getting a queen is 0. Is that clear? Can we go for next question? So here we will go for next question, that is question number 16. 12 defective pens are accidentally mixed with 132 good ones. Okay, I will write here solution. See, 12 defective are there plus 132 good ones are there, are mixed again. What is the total number of pens now? It is 144, the total number of pens. It is not possible to just look at the pen and tell whether it is good or defective. One pen is taken out at the random, what is in a lot. Definitely, you need to determine the probability of that taken out pen is good one, right? So, what is this 12? Number of defective pen is 12, and number of good pen is 132. Total number of pen is 144. What is the probability of getting a good one? Good pen. Good one is equals to number of, how many number of good pens are there? 132. And how many are there totally? That is 144. The answer is 132 divided by 144. You can keep or you can solve this problem. Here is 11 1 the 11, 11 2 the 22. Here is 11 on the 11, 11 1 11 11 the 11 11 the 11 on the 11, 11 to the, I think this is 152 total number is. Hmm. To the 11 on the 22 is remaining. Okay, wait. One 32 divided by 144. Determine the probability that the pen taken out is good one. It is one. Okay, 12 out of 12. 12 on the 12, 12, 12 on the 12 again. Here also 12 on the 12, 12 to the 24. And the answer is 11 by 12. The probability of getting a good pen is 7 by 12. Here, 1 here. So this is question number 16. Can we go for next question? Question number 17. A lot of 20 bulbs containing 4 defective ones. One bulb is taken out at the random from the lot. What is the probability that the bulb is defective? See, right solution here. A lot of 20 bulbs containing 4 defective. See, there are total 20 bulbs are there, out of which 4 bulbs are defective. 4 bulbs are defective. And how many remaining good one are good bulbs? Out of 20, if you remove this 4 defective, the remaining is 16 bulbs are good. What is the probability that the bulb is defective? The probability of the bulb is defective is how many defective are there? 4 defective out of 20. That is 4 1 ja 4 5 ja. 1 by 5 is the probability of getting the defective one. And in second case they given, suppose the bulb drawn is not defective and is replaced. It is not replaced, defective and it is not replaced. Now the bulb is drawn at the random from the rest remaining. What is the probability that the bulb is not defective? See here, one bulb we took and the remaining bulbs are 19 only now. 19 only remaining bulbs are there. And now what there are good bulbs. How many good bulbs are there? 16 good bulbs are there. Out of 16 good bulbs, what he is telling, see, now one bulb is given. Suppose the bulb is not defective and is not replaced. Means, see, if it is not defective, then what it is? It is a good one. Means out of 16 good bulb, one bulb we removed already and remaining how many good bulbs are there? 15 good bulbs only. What is the probability that the bulb is not defective? Not defective means what? Good. How many good are there? 15 good are there. How many total remaining? Total remaining is 19. So the probability of getting the good bulb only here now. The probability of getting the good bulb is 15 by 90. 16 good bulbs are there, out of which one we removed. Remaining how many good bulbs? One good bulb. Out of 20 also we removed one. How many remaining totally? 19 is remaining. So the probability is 15 by 19. This is the probability of a bulb which is not defective. Next is question number 18. A box contains 90 discs which are numbered from 1 to 90. 90 numbers are 90 number of discs are there which are numbered from 1 to 90. If one disc is drawn at the random from the box, find the probability that it yes, the removed disc should have that number. Which number? A 2-digit number. It should have a 2-digit number. See the numbers between 1 to 90. You go on imagining. How many two digit numbers are there out of 90? 90 numbers. See, if we remove the one digit number, remaining will be two digit numbers. How many one digit numbers will be there between 1 to 90? 9 one digit number will be there. One digit. 9 one digit numbers will be there. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. That 9 if you remove, that is 90 minus 9 if you remove, how many is remaining? 81 two digits numbers are there. Two digit number, how many are there? 81. So the probability of getting a two digit number is, therefore the probability of getting a two digit number is equals to 81 by 90. Clear? Second one, getting a perfect square number between 0 to 90. How many numbers are there between 0 to 90 which are perfect square numbers? I will write here. One is the perfect square of 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, 10 square is 100. It will not come. How many are there? Will count now. Here you see 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers are there between this which are perfectly square. Here you can do 9 9 81, 9 10. So the probability is 9 by 10. And here how many are there? 9 numbers are there. 9 by total numbers are 90. 9 ones are 9 10. And the probability is 1 by 10. And in third question, it is a divisible by 5. How many numbers are there between 1 to 9 divisible by 5? You can write 5 on the table. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, and 90. 90 we should not include because between they ask, right? So how many numbers are there? Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. It will come because that may 90 may also come. 85, 90. Sorry. So how many numbers are there? 18. The answer is 18 by 90. Now you divide. So it is 18 on the 18, 18 5 is 90 directly. The answer is 1 by 5. What is this 1 by 5? 1 by 5 is the probability of a number which is divisible by 5 and it may come between 1 and 90. Right? This is question number 18. Can we go for next question now? A child has a die whose 6 faces are as shown in the letters below. A, B, C, D, E. Again, I is repeating. The die is thrown once. What is the probability of getting A and D? In first case, the probability of getting A. The probability of getting A. How many total are there? You see, 1, 2, 3, 4, 5, 6 are there totally. Out of 6, how many A are there? Here also A, here also A. How many are there? 2. 2 by total is 6. 2 1 ja, 2 3 ja. So the probability is 1 by 3. Right? And here is a D. Probability of getting D. They were asking you to find, and the probability of getting D is equal to how many D are there? Only one D is there. Only one I will take divided by 6. So it is 1 by 6. Am I correct? Over this much. It is easy. Question number 20. Suppose you drop a die at the random on the rectangular region as shown in the given figure. What is the probability that it will land inside the circle of diameter 1 meter they given? Here you see the diagram, you see, you come to know this diameter is given. If you are throwing a die, where it will fall, either on this surface or in this surface. Or see this area by this total area, small area by total area, probability how we will be doing, right? So area we need to find and we need to divide. Solution: area of rectangle What is area of rectangle? Length into breadth. 3 into 2. 6 meter square. What is area of a circle? Formula is pi r square. Here 1 meter they given is diameter. If 1 meter diameter is 1, then what will be the radius? It is 1 by 2. Let pi r square, that is pi into radius is 1 by 2 whole square, which is pi into 1 by 4. That is pi by 4. What we will get if you divide pi by 4? Therefore, probability is equals to pi by 4 into 1 by 6. That is pi by 6 over the 24. This is the answer. We just divide the areas. Area of circle divided by area of rectangle. That is small area by large area, or like how we will be doing in the probability, number of outcome or favorable event divided by favorable event. What is the probability it will land in the circle? It is our favorable. Favorable is circle. Circle by rectangular area we need to do. This is the solution of 20th question. So we will go for now 21st. A lot consists of 144 ball pens, of which 20 are defective. Out of 144, 20 ball pens are defective and others are good. Noori will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at the random and gives it to her. What is the probability that given pen she will buy or not buy? When she will buy if it is good, when she will not buy if it is defective. Means they were asking you whether the removed pen or whatever the drawn pen is good or defective, they were asking. So what we will write? Write solution. So I will write total 144 pens. Out of defective 20 pens. And how many good pens are there? If you remove this 20 from the 144, that is 124 good pens are there. First one is the probability that she will buy. What she will buy? She will buy only good pens. Means what we need to do? We need to go for number of good pens by total number of pens. That is 124 by 144. Divide and write the answer. 4 3s are 12, 4 1s are 4, 4 3s are 12, 4 6s are 24. The answer is 31 by 36. And in second, what is the probability she will not buy? The probability she will not buy. Two methods are there. Either you can take the defective pen 20 by 144 you can do, or you can go for 1 minus of this. Any you can 1 minus of 31 by 36 you can do. That is 36 minus 31 by, if you take LCM here into 36 you need to do here into 1. That is 5 by 36. 5 by 36 is the answer. Or if you are doing the directly, then it is 20 by 144. Here also 4 5 are 4 3 are 12, 4 6 are 24. Again you will get same answer. Any you can do, right? So this is about question number 21. Can we go for question number 22 now? So here they given two dice. One is blue in color, one is grey in color, are thrown at the same time. Write down all the possible outcomes and complete the following table. See, they given the sum of two numbers. If we take the sum of two numbers as 2, 3, 4, 5, 6, 7, 8, 9, 10, maximum is 12. This question we need to understand. See, to get this number, what is the possibility? The possibility is 1, 1. If we add 1 and 1, you will get 2. Over. No other possibilities to get 2. Right? And to get 3, what is the possibilities? 1, 2 or 2, 1. Two possibilities are there. See, if the possibility is 1, the answer is 1 by 36. Right? Why it is 1 by 36? Two dice are there. See, whenever two dice will come, we need to do like this. 6 into 6. That is, total 36 outcomes are there. Total 36 outcomes are there. That is the reason why we will be dividing it with total number. That is 36. And here, how many possibilities? Two possibilities. The answer will be 2 by 36. To get a number, sum is 4. What is the possibilities? See, the possibilities are 2 comma 2, 4. 1 comma 3 is 4. 3 comma 1 is also 4. So how many possibilities are there? 3 possibilities are there. So here the probability will be 3 by 36. Similarly, here will be 4 by 36. Here will be 5 by 36. Here will be 6 by 36. See, after this they given a clue here. You can see 5 by 36. After 6 it is reducing because only 36 possibilities are there. And only 6 is the maximum number which we can get. So after it is 5 by 36. Then we will be having 4 by 36. Then we will be having 3 by 36. Then we will be having 2 by 36. At last they give it is 1 by 36. It is 12. 12 when it is possible. When we will get the sum as 12? It is possible only at 6 comma 6. If you get 6 comma 6, then only the sum is 12. Only one possibility. That is 1 by 36. Right? So here they given a student argues that there are 11 possible outcomes 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 and 12. Therefore, each of them has a probability. It is not like that 11 possibilities are there. Do you agree? No or not? Because each individual probability is different. Depends on the type of word how we are using. So that is the reason why we need to find the probability of individual 1 to 6 and 6 to 1. It is going to vary. Is that clear? The next day in question number 23 they given a game consists of tossing 1 rupees coin 3 times and noting its outcomes each time. Hanif wins if all the tosses of the given results are same. 3 times you are means same it should come. Tail, tail, tail 3 times it should come. Or head, head, head it come. Then only he will win. Or else he will lose otherwise. Calculate the probability that Hanif will lose the game. See, I will explain. Write the solution. What is the total number of outcomes we will write? 3 coins tossing. 3 coins. What is the possibilities will come? Head, 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 tail, 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 head, head, tail, 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 head, head, tail, head, tail, head, tail. How many are? 1, 2, 3, 4, 5, 6. Then head, head, tail, 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 head, tail, head, 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 tail, tail. How many are there? 8 outcomes are there. So number of outcomes are 8. There are maximum 8 outcomes will be there. Out of these 8 outcomes, he will win only at 2 times. Whenever there exist all 3 heads, whenever there exist all 3. Then if we remove these 2, how many is remaining? So only 6 outcomes will be there. This is what he will lose. So therefore, the probability that he will lose is 6 by 8. That is 2, 3 ja, 2, 4 ja. The answer is 3 by 4. The answer is 3 by 4. That is the possible outcomes. Then we'll go for question number 24. A die is thrown twice. What is the probability that 5 will not come up either time? 5 will come up at least once. At least one means minimum 1. Means 5 will be there. We need to take 5, 6, 7, all those things. Right? So write solution. A die is thrown twice means the total possibilities will be 6 into 6. That is 36 will be the total outcomes. So first one is 5 will 5 will not come up either side. See, out of 36 times, how many times the 5 will not come up? 5 will not come up, right? So 5 will come up. We'll take 5 comma 1. It may give 5 comma 2. It may give 5 comma 3. It may give 5 comma 4. It may give 5 comma 5. It may give 5 comma 6. How many are there? 1, 2, 3, 4, 5, 6. This is one possibility. Second possibility is 1 comma 5, 2 comma 5, 3 comma 5, 4 comma 5, 5 comma 5 we wrote already, and 6 comma 5. These many possibilities are there. We need to remove. In these all time the 5 is coming. Right? They are asking you will not come. How many are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 are there. So out of 36, if you remove the 11 possibilities, how many is remaining? Remaining is 25. Out 25 times the 5 will not come. They are asking 5 will not come only. So therefore the probability that 5 will not come, with 5 will not come is 25 by 36. And in second case they are asking what is the probability of 5 will come. How many are there 5 will come out of this? In all these cases the 5 will come up. Right? How many are there? 5 will come up. So the probability of 5 will come up is will be 11, 11, 11 by 36. 11 by 36 is the probability in which the 5 will come up. Right? This is about question number 24. Okay guys, can we go for the last question of this exercise? Which of the following statements are correct and which are not? Give reason for your answer. They are asking you whether given is probability is true or not. Whether it is given statement is correctly, probably whatever they said is correct or incorrect. If two coins are tossed simultaneously, there are three possible outcomes: two heads, two tails, or one each. Therefore, for each of these outcomes, the probability is they are asking, that is 1 by 2 they were giving. It is not like that. The statement is wrong. Two coins are tossed simultaneously means the probability will be, or the total number of outcomes will be 2 into 2 is equals to 4. And each time, each case, the probability will be 1 by 2 out of 4. Because head head, head tail, tail tail, tail head. Therefore, 4 will come. If you take this head head, the probability is 1 by 4. If you take this, again the probability is 1 by 4. If you take this again 1 by 4, and if you take this again 1 by 4, and the probability will be always 1 by 4 in this condition. So therefore, the given statement what they are telling is incorrect. The first one is incorrect. Here is the reason. Because individual probability is 1 by 4. And in second case, if a die is thrown, there are two possible outcomes: an odd number or an even number. Therefore, the probability of getting an odd number is, the given it is equally likely event. Correct. In second one is correct, because out of if we throw a die, then the number we may get is 1 or 2 or 3 or 4 or 5 or 6. We may get any number out of this. But in this there are 1, 2, 3 odd numbers are there, and 3 even numbers are there. See, this 3 and this 3, this 6 is equally likely divided into 3 odd numbers and 3 even numbers. Then the probability of it whatever we'll get will be 1 by 2 only. Therefore, the given statement is correct. Am I clear? So here we completed the first exercise of the probability. So please do read write practice and see whether if you have any doubt, please do ask me. Then we can go for finding the solution of the next exercise, that is probability 15.2. We will solve in the next class. So please do read write practice and enjoy learning mathematics and follow Patil virtual classes.